Hi guys, I wanted to record a quick video for you guys to talk about a technique used in the crime lab to differentiate different types of inks. It's really a separation technique, and it's called thin layer chromatography. This particular video will be helpful for the lab exercise you're going to do in Module 6, which is on question documents. So to give you some background on when this technique would be useful, let's imagine, for example, that I was writing a check. Maybe I was writing a check to somebody, and so I wrote the check out to John Doe, and then I wrote the check out for, let's say I made it out for $100, $100. And then I took that check, and then I gave it to John Doe. And then when John Doe received that check for $100, let's say John Doe decided that he wanted for that check to be more than just $100. Let's say he wanted to make it for $1,100. So when he got this check, he took a pen, a different one than the one I wrote the check with, and he added another one at the front. And so now our $100 check has been changed into an $1,100 check. Now, this check would be an example of what we call a question document. So a question document in the crime lab could be a lot of things. It could be a forged document, so a forged signature or a forged credential like a forged driver's license or a passport. It could be something like counterfeit money. But this is an example of the type of evidence we might receive in the question documents unit. And so let's say that the authenticity of this check, or maybe whether or not this check has been doctored or not, became an issue in a case. And so what we'd like to take a look at is, are the inks used to fill out this check from the same pen or not? And so one of the techniques we could use to do that would be a technique called thin layer chromatography. So chromatography, what is chromatography? Chromatography literally translates to the separation of colors. And so thin layer chromatography, especially as it has to do with inks, allows us to separate inks that are mixed together to make various hues. Now chromatography, there are various forms of chromatography used in the crime lab. Thin layer chromatography, which is what I'm going to be talking about and demonstrating in this video, is one type of chromatography. It's used on things like inks, but it also can be used to analyze drugs. For example, if we have a marijuana pipe that we think has THC or marijuana residue in it, we can actually test the residue in that marijuana pipe, in the bowl of that pipe, for the presence of cannabinoids like THC using thin layer chromatography. So thin layer chromatography has use not only in the question documents unit, but we can also use it in the drug unit. There are other forms of chromatography we also do in the crime lab. For example, in the drug unit, we do a type of chromatography called gas chromatography. Gas chromatography uses an instrument called a gas chromatograph, or a GC, which has a very long tube, almost like a straw. It's a really, really, really long tube. It can be as many as 10 or 20 meters or 10 or 20 yards in length. And then it's wound in a coil, and then our samples pass through this long tube or coil, and that coil or that tube, or what we call a column, that's the term we use for it, actually can separate the components of a mixture. Because that's what chromatography is all about. Chromatography is about separating the components of a mixture. Another type of chromatography is what's called Hplc, which is high performance liquid chromatography, which is another form of chromatography. Again, it uses a column, not unlike a gas chromatograph, and the sample passes through the column and then separates out. But instead of using gas to push it through the column, which is how gas chromatography works, high-performance liquid chromatography, or Hplc, uses a liquid that pushes the sample through the column. The concept being, imagine that I was going to go down a water slide. So maybe me and a group of friends, we're all clumped together at the top of a water slide, and we all start going down the water slide together. Those of us who are maybe bigger, heavier like me are going to go down that slide much quicker than those who are smaller and maybe more slender. So what's going to happen is, as we go down the slide, some of us are going to go down the slide quicker, others of us are going to take a longer period of time. And so what's going to happen is we're going to begin to separate out. Or you can think about it in terms of like a race. Imagine that you and I and maybe several other 100 people are going to run a race. And so we're all sitting at the starting line getting ready to run that race. Well, we all start at the starting line in this big group or mixture. And then as the starting gun goes off, we all start running the race. Well, those of us like me, which are bigger and heavier, we don't run very fast. And so as we begin running, those who are in much better shape or better runners, they start to separate out from those of us who are slower and out of shape. And so they end up running the race faster than those of us who are more out of shape. We take a lot longer time. And so the group begins to separate out based on how quickly they run that race. And so that's the kind of the concept behind chromatography. Chromatography allows a mixture to separate out as it travels. When we do chromatography, there's a couple things that we have to keep in mind. We keep in mind something called the stationary phase, and then we also keep in mind, or we consider something called the mobile phase. Using the analogy I said before, the water slide. If a big group of us are at the top of the water slide and then we all go down the water slide together, the slide itself would be what we call the stationary phase. The slide doesn't move. The mobile phase is the thing that actually pushes us down the slide. So in a water slide, that would be like the water rushing down the slide, pushing us down. So in liquid chromatography, what we do is we take a liquid, usually a solvent of some sort. The solvents we're going to be using for thin layer chromatography are acetone, which can be found in good old nail polish remover, and then also alcohol. In this case, we're going to use isopropyl or rubbling alcohol. Those solvents, what we can do is we can actually use those solvents to move inks along a stationary phase. And the stationary phase, which we're going to use, are going to be just these 3x5 cards. What we can do is if we take a marker, something that has ink in it, if we put a dot on the card, so here I have a dot of ink, and then if I carefully pour some of my solvent into the bottom of a jar or a cup, and then if I place the card down into the liquid, I've got to make sure that the level of the liquid doesn't come all the way up to the ink spot. I want the layer of the liquid to be just below. But then because this 3x5 card is made of paper, the liquid is going to begin to get sucked up by the paper through a process called capillary action. So the liquid will actually begin to travel along the length of the paper. And so what's going to happen is that ink will be slightly dissolved by the solvent, and then it'll begin to travel along with the liquid as it moves upwards. So in the case of thin layer chromatography, our sample is the ink. The stationary phase would be the card, and then the liquid moving up along the card, which is actually moving the ink, that would be what's called our mobile phase. And how far the ink travels is going to depend on how much interaction it has with the stationary phase of the card, and then also how soluble it is in the mobile phase or the liquid. So that's why we're going to try a couple different liquids. So what I'm going to do is I'm going to take my card and I'm going to place it down inside my jar, and then what will happen is the paper will begin to kind of suck up that alcohol. It'll begin to rise along the card, and then it'll begin to carry the ink, and we're going to get these streaks of ink. Now, because black ink, which was what was in this marker, is actually usually a mixture of a few other colors, what we're likely to see is we'll start to see streaks of yellow and blue and maybe even red ink mixed together to make the black. And so what will happen is those various components will begin to separate out along the length of the mobile phase. So this is the process of thin layer chromatography. Again, we can use this to analyze inks, we can use it to analyze drugs. There's a lot of things that thin layer chromatography can be used to analyze. Ultimately though, chromatography is a separation technique. That's the thing to remember. Whether you're doing thin layer chromatography, where you're using a thin piece of cardboard or paper, or if you're using gas chromatography where you have a tube like a straw and you're forcing a gas which is pushing the sample through, where the gas is the mobile phase, or high performance liquid chromatography where liquid is actually pushing the sample through the tube. All of these are separation techniques where we're going to separate out the components of a mixture. And then we can identify each component within the mixture based upon how far they traveled. In gas chromatography, where the sample travels all the way through the column, the way we identify the constituents is by how long it took to go through. We know, for example, that larger molecules take longer to go through. So a big heavy molecule like heroin, for example, takes a lot longer to go through than a really light, simple molecule like methamphetamine, which zips through the column really fast. So if we had a mixture of heroin and methamphetamine, we could inject that mixture into our column. The methamphetamine would come out first at a certain time period. In fact, the length of time it takes to go through the column, we call that its retention time. So maybe we inject our sample, which has a mixture of heroin and methamphetamine. The methamphetamine goes through the column. Again, I'm kind of doing the circle because it's a spiraling tube. It comes out the end, let's say after about 2 minutes, whereas the heroin might take 7 or 8 minutes to come through. And the length of time it takes from the time that you input or inject the sample into the column until it comes out the other end is what's called its retention time. That's in gas chromatography or high-performance liquid chromatography. But in thin layer chromatography, what we're going to record is how far along the stationary phase the sample went compared to how far the liquid actually went. So anyway, that's chromatography. I'm going to record another video showing you exactly how we're going to use this concept of thin layer chromatography to analyze inks.